Hey there, IT 145 students. So in this recording, we're going to go through the first part of chapter 2, and that is creating methods or functions. So I know in your intro programming class, in the Python class, you create methods in that course. So keeping the idea that we create methods in order to perform some kind of operation repeatedly. So if we know that we're going to repeat some kind of code, we want to create a method that handles all of that functionality. So for instance, they give us starting out converting a temperature. So we know that to convert a temperature, we have to subtract off 32 and then multiply by 5/9. And we can see right here that they repeat this code 3 times. And sometimes you perform an action and have an error in the calculation. So for instance, the top two here, these were performed properly, but then down here, there's an addition sign instead of a subtraction sign. So what we'd like to do is create a function that performs the functionality for us. So in kind of pseudocode format right here, we have this Fahrenheit to Celsius method. It's going to take in the Fahrenheit temperature as a parameter. And we know that the right formula is to take the Fahrenheit temperature minus 32 and then multiply that result by 5/9. And so at the end, we return back the value that is the Celsius value. And so now we have a much simpler way of performing this action. And we can avoid this kind of potential error where we make a mistake in the calculation. And then other thing we can do is if we ever need to modify this implementation, we have to do it only in one place. We don't have to go to every single location where it's used to modify that method. So scrolling down, uh, we have the idea of a method to calculate pizza area. So here is a method in Java. So we have the method name calculate pizza area. That's great. And so in here, they have a variable for the diameter, the radius, the area of the pizza. That's what actually wants to be calculated. We have a value for pi. Probably should have made that a constant, but that's okay. And then for now, they've just hard coded in the diameter of the pizza that we are calculating for. So we should know that the radius, that's the pizza divided by, that's the diameter divided by 2. And then the area is pi times the radius squared, or you can just multiply the radius twice. And so at the end, we return off the pizza area. So again, keep in mind, this functionality is going to calculate the pizza area. And for now, this just hard codes in the diameter. We'll eventually make this where we can send it a different diameter, but we can then call that method right down here inside our main method. So let's go ahead and just get this code up and running. So I'm going to create a new project. We'll call this module 2. Finish. And we'll add a source file in here. I'm just going to call this methods. And I'll go ahead and have it create a main method for us. And I'm going to copy this calculate pizza area method. And then we're going to copy the main method code right here. All right, great. I don't see any syntax errors. So this all compiles just fine. So keep in mind this main method, when it executes, it's going to come down here and say, oh, you want to use the calculate pizza area method. So the method is where we'll then end up. So if I were to put a breakpoint in here, and I'm going to hit the debug button. Let me right click it and debug as. So we can see that the code is paused. It's waiting right here for us to tell it to step through. So let's do a step into, step return, step into. Yep. Now it'll go into the calculate pizza area method. So not inside this method. And again, I've got variables, diameter, radius, area. Those have not been initialized yet. And so now I can step through and I can see that the diameter was 12, the radius is 6, and then this is going to calculate the area. And so right there we can see that the area is about 113, and then I can step over. That is going to return back the value 113-ish. So if I highlight this, and if I do a Control Shift I can see what that value is, and it's going to be about 113 right there. And so when we step over for the last time, we then get the output displayed right there. If we wanted to play around with this, we could make this 10. We're going to get a different value. Let's go back to the Java perspective. So if I put in 10, then it's a little bit less. Obviously, I didn't change this right here. So make it make more sense. So 10-inch pizza is about 78.5 inches squared. So great, we've got this method that we can work with to start out. Oh, by the way, they are making the methods public static. So in Java, you have to provide a access modifier to describe what can access your method. And in this case, public means anybody that has access to this class has access to this method. Oh, by the way, the only time that you're going to declare a method here like this static is if it's going to be referenced in the main menu. Excuse me, in the main method. If I do not have this as a static method, this is going to complain because the static main method can only reference static variables or static methods. So this needs to be defined as a static. You'll see later on when we create a class a better usage of static, but for now, because this is being called in the main method, we have to declare it as a static. Again, we saw in this method that we are performing some action. We're calculating a value. And so we have a return statement in here. So at the very end, we like to have one single return statement if this method returns something. And so right here, it's at the very end. Because this returns a value, we have to have the data type that this method returns. So in Java, we have our access modifier, and then the next thing we have is the return type. So if we were returning an integer type, then this would be int. This could be whatever data type you need to return. It makes sense that the calculate pizza area method returns a double because we are going to be halving and we're going to be multiplying by pi. So those are definitely potential double type numbers. So here's an example. They have a method to compute the square of something. They are providing an integer value. So the parameter is an integer value, and then if you multiply two ints, you're going to get an integer value. So they are making this return an int value. So just like in your intro Python course, methods become more useful when we provided some input to it. So keep in mind, we have this calculate pizza area method that as it stands, the diameter is a hard-coded number. Well, what we're going to do is we're going to pass that as a parameter. So now we're going to just copy that and we're going to paste it right here. So now instead of declaring a variable inside here for the diameter, we can get rid of that. We can get rid of this hard-coded equals 10. And so inside this method, it has access to this parameter value called pizza diameter. So if we send it 10, it's going to come in here as a 10. If we send it 12, it'll be in here as a 12 and so forth. Now, you can see down here that we have a syntax error because we have not provided the appropriate value to this method. So let's just come in here and we'll give it a 10. We'll copy and paste and we'll do 12, and that's going to be a 12 right there. So now when we run this, let's just put a breakpoint inside our method right here. So let's debug, and you're going to see that this time, first one, it got called. It's this right here. The pizza diameter is coming in as 10. Okay, great. Next time it's going to be sending in 12 for this line right here. So pizza diameter, hover over it, you can see 12. You can also open up the variables window over there, and you can see that it's a 12 there as well. So the 10-inch pizza is about that 78.5. We were getting that earlier. And the 12-inch pizza is about the 113 inches squared. Again, we were getting that earlier. So now we have the ability to send any size diameter to this method, and then we get its area returned. So methods can have multiple parameters. So you can see here, they're going to calculate the pizza volume. So let's just copy this right here. So now we've got a method to calculate pizza volume. And so not only do we have the diameter, but we also have the height. And take a look here. They even do this. They have the pizza area. They're going to calculate it right here. Well, don't we have a method that performs that? Couldn't we do this? Can't we do calc pizza area, sending it the pizza diameter? So, hey, that's looking good, right? We get the area. And from your geometry classes back in the day, keep in mind the volume of something is always its area times its height. So that's a really simple little formula here. And let's see what we have in here. So originally, remember, they had the calculation of the pizza area in here. So we got rid of that. And look, I don't need pi in here. This is telling me that this variable isn't used. So we can actually delete this. And the radius isn't used in here as well, so we should delete this as well. And we don't need pizza radius. And great. So now we have the bare bones, what we need for this calculate pizza volume method. Oh, by the way, you can see how the indentation here is kind of off a little bit when I copied and pasted. One thing I can do inside of Eclipse here is I can highlight the code, right click it, go to source, format, and it's going to format it nicely. It's going to do indentation for us, line up the curlies, and so forth. Just like before, we could calculate the pizza area. Well, we can calculate volumes. So let's just go ahead and copy what they have here. I'll comment these out. And so now they're going to calculate pizza volumes. So we have diameters 12 and a height of 0.3, diameter 12, height of 0.8, diameter 16, height 0.8. So now when I run this, we get the volume of those pizzas. Now, one thing that newer programmers struggle with is they don't understand which order things are supposed to be sent to this method. So one thing that we can do is we can hover over the method here, and it's telling us that it requires a diameter first and then a height second. That's the reason we used good variable names. We could have just done this, call this X, call this Y, this is X, this is Y. And so now, if I come down here, I have no idea what these variables represent. So we always want to use good naming conventions, not only for variables, but also for parameters. One other thing to point out, and we've seen this before, is, again, this only gives us a little bit of detail. I see that it returns a double, and I know that it takes a double for the diameter and a double for the height. Well, we could strengthen this by performing some JavaDoc notation. So / 2 stars, press the enter key, and then this method calculates the volume of a pizza. We're going to provide a description for each parameter, the diameter, the height, and the return value is return the volume of the pizza. So the reason we perform some JavaDoc is when I hover over this method, I can see what it does. So it's telling me that this calculates volume. Yep, got it. And then I also have descriptions of my parameters. And I also know what it returns. So remember, before we had X and Y here. So if I make this X, if I make this Y, and again, shouldn't do this, but I can. Because I've got some good JavaDoc, I can come in here and I can see, oh, look, X and Y, this is the diameter, this is the height. Oh, okay, so that's the order in which I need to send things. But we're going to make sure that we use nice variable names, so we'll go back to that diameter and height right there. Oh, by the way, again, they have the idea that this takes two parameters. It's totally possible that you have methods that don't take any parameters. How do you know if a method takes parameters? You have to just do some thinking. To calculate the pizza volume, we had to know the diameter, we had to know the height. To calculate the area of the pizza, we have to know the diameter. So think about what you need to know, and then those become your parameters. Just like we saw here, again, we can call methods from methods. So I'm calling the calculate pizza area from the calculate pizza volume method. Again, those are perfectly legal things to do. Okay, section 2, they're going to talk about methods that don't return anything. So if a method isn't supposed to return something, then it is called a void method. And so we have the void keyword for the return type. So right there, this print summary method, this is going to be a void method. It's going to do some work, but it's not going to return anything at the end. Whereas these methods, calculate pizza area, calculate pizza volume, these return a double. So if you know that you're going to get a value back or get something back, then you need to have a return type. Otherwise, the return type is a void. So here, there you've got a void method to print out some summaries. Great, sure. Again, it's a method, so you can call it multiple times. So they've got this method called print greatest. It takes in a word that's a string. And then you can see in the code, they're going to print the greatest, and then whatever word came in, and then on earth. So sure, you get a little print method right there. Again, this is a void method because this does not return a value. If we create this method, and if I do not have, oops, I thought I copied all that, but apparently I didn't. So let me get it all copied. And there we go. Nope. What in the, I've got all sorts of stuff copied there. How about this? Let me do this. It's just being very difficult. So here, we'll copy a little bit of it, and this will just be Word. Sure. So keep in mind, if you don't specify void here, we're going to get a syntax error. And it says return type for the method is missing. And if we're not returning something, it needs to have the void keyword. Okay. Okay, in the next section we're going to look at, they just provide some details about why we want to define some methods. They point out that defining methods improves program readability. Um, Really, what we want to do is we want to create methods that perform work that we know is going to be repeated multiple times. So for instance, we might be wanting to calculate how many steps to miles. We might want to calculate how many steps there are to calories. And so we encapsulate this functionality together. Otherwise, if I don't do this, every time I want to figure out how many steps there are to miles, I have to copy and paste the exact same code and perform that work. And that's just not worth doing. If we make a mistake, we have to change it multiple places. So what we want to do is we're going to encapsulate the functionality as a method. And then if we need to make changes, we'll have to change it here once, and we can use it wherever we want. And I'm trying to think if there's anything else in here. So in here, they do mention, so we want to avoid writing redundant code. So anytime you find yourself copying and pasting the exact same code, um, you need to create a method for that. Okay, it's called dry programming. Don't repeat yourself. So always look to create methods when you are copying and pasting things. Okay, we're going to skip ahead to section 2.7. And the last section we'll talk about here is scope of variables and methods. So scope relates to where you can see a variable or a method. So which parts of a program can you see those things? So if we declare variables inside a class here, so if we declare variables inside this class, they are accessible anywhere in the class. So these two right here, we would call these class level variables. I can see them anywhere in this code for the height converter. Now, inside a method, we can declare variables. So you can see here they declare a variable called total in, a variable called cmval, so this is the centimeter value. These two methods are declared inside this method. You can only access them in this method. If I try to reference cmval, it's not going to be this. In fact, if it doesn't exist, it's going to be a syntax error. So let's just copy and paste. Let me grab this too. And we'll just create a new class for it, just like they have. New class. We'll call it height converter. Oops. New class name. Here we go. Height converter, create it. And let's paste the code that they gave us. And we have to also have that import. Okay, so here's that variable total in. If I try to reference total in here, I'm going to get a syntax error. It's going to say it cannot be resolved to a variable. It doesn't know about it in this main method, and we probably don't want it to know about that variable. So we only need this variable right here when we're performing this calculation. So you don't make everything global variables or class level variables. You limit the scope of the variables. I only need these two right here, so they're only available here. Inside this main method, we have a scanner used to read input. Well, the only place I can access this scanner variable is inside the main method. Watch this. If I try to use scnr, I can't because it's going to say it cannot be resolved to a variable. So we limit the scope to where things need to be accessed. So we need the scanner in the main method. Sure, it's available right there. The user feet, user inches, we're only going to get those typed in from the user during this main method. So we don't need to have them declared at the highest level here. So always, always, always look to limit the scope of your variables. And then the same thing will apply to methods. We'll see again in the next section where we create methods for our objects. We might have some methods that are only used within the class. So instead of making them public, we might make them private. One other thing I want to mention while we're here, they didn't have it in the zyBooks here, is when we have parameters to methods and they're a primitive data type like we have here. So int values, these are primitives. They come with the Java language, just like double, float, char, byte, boolean. So this height feet, this height in, these parameter values, what happens is when we call the method, we actually send a copy of the values that these variables contained. So I know it seems a little confusing. think about it this way. We came in here, we typed in a number for user feet. Let's say that we type in 6, and then we'll type in 2 inches. So user feet holds 6, user in is going to hold 2. When we call this method, it's going to send a copy of those values to this method here. So I get a copy of 6, I get a copy of 2. I don't get access to the actual variables user feet, user inches. And that's big because if I make changes to these two variables, they will not actually make changes outside of the method. So for instance, for fun, we'll say height feet equals, we'll say 8 feet, and height inches, we'll say 11. So this would be somebody that is 8 feet, 11 inches. Again, I can see that this is not complaining. I'm allowed to do this. But if I come down here, the first one is the feet. And the second one is the height, inches. So I'm going to put a breakpoint here. So we're going to see that we will type in 6 feet 2. So we're going to see the 6, we're going to see the 2. However, when the method potentially makes any changes to those, it does not change the variables that were sent. It's only changing the values of the parameters. So let's debug. Oops, this is height converter, so debug this. Debug as, there it is. So enter feet, we're going to type in 6 inches 2. Great. So we have 6 feet 2. We're going to step into our method. So height in feet is 6. Height in inches is 2. Great. And look, we changed the height in feet 8. Height in inches 11. So those are the local variables to this method. So we've changed those values. But look, when I come back, the original values are 6 and 2. So you can change parameter values here, but it does not have any change effect to the initial values. So keep in mind that's true for primitive types, not true for object types. And we'll talk about that in our class later. Okay, so that is the details for methods. I will talk to you next time.